Morning. Good morning, everyone. This is ICT class. I would like to discuss with you a topic called microprocessors in control application. Microprocessor in control applications. On your screen, you can see two objectives expected to be achieved at the end of today's lesson. The first objective is all about how microprocessor controlled devices work. How microprocessor controlled devices work. So it means that at the end of today's lesson, we are going to learn how microprocessor controlled devices work. And the second objective, which is the last objective, is all about how microprocessors control is used to control devices. So now let's move to the next slide. The next slide is all about introduction to this lesson. Microprocessor control applications. Microprocessor are tiny computers embedded in household items. Another name for microprocessors is what is called microcontrollers. Microcontrollers. So microprocessors are tiny computers embedded in household items such as televisions, washing machines, burglar alarms, and greenhouses. Through the use of input and output connections, they can monitor and control the devices in real time. So it means that all these devices at home are being controlled by microprocessor automatically. Now, below this definition of microprocessor is preset values. Preset values. So we're talking about preset value. We are talking about the value set which microprocessor will work with. So microprocessor control applications often use input sensors with preset values. These values are used to control when certain actions will happen. When certain actions will happen. Now on the screen, you can see some control applications. So on my screen here, I have about 4 control applications. Number 1 is automatic cookers or ovens. Number 2, central heating system. Number 3, greenhouse environmental control. And number 4, chemical process control, and many more. So now let's move to the next slide, where we are going to discuss how microprocessor can control automatic cooker or oven. Sensors and microprocessor are also often used in control devices. In the exam, examiners will expect you to understand how microprocessor is used to control an automatic cooker or oven. Now, what are the steps taken? The following steps outline how it's set. So the first step is user input the amount of time required and the cooking temperature. The user input the amount of time required and the cooking temperature. Then the second step, the microprocessor check the set time against the current time. So this one is all about time. So you can see the condition. We have two conditions under this step. The first condition is if it's within time, the cooker remains on. That is, if the time is still within the preset time, so it means that the cooker remains on. Then the second condition, if it's outside the time, the cooker turns off and send a message to a beeper. That beeper is a sound. We can even call it a warning sound, or a sound that will call the attention of someone that is making use of the automatic cooker. Now, the last step here, the system also checks the temperature. The system also checks the temperature, because temperature here must be what? Must be considered. For example, if you want to use a cooker, maybe to boil water or something like that, we all know the temperature level of water. I mean the boiling point of water. Before you can conclude that your water is hot enough or is boiled enough, you have to consider the temperature, and the temperature is what? 100 degrees Celsius. 100 degrees Celsius. So if the temperature of that water is above 100 degrees Celsius, it means that the automatic cooker will off by itself, because it is within the preset value, which is the what? The temperature. But if the temperature of the water is below 100 degrees Celsius, that device will still be working. So if it is above the preset value, it will turn heating element off. If it is below the preset value, it will turn heating element on. So I hope I am communicating with somebody here. Yes. So now let's move to the next slide. Yes. So we are going to discuss how microprocessor control central heating system here. Central heating system. A central heating system is a system that is used to heat a house when it is cold outside. When it is what? Cold outside. Examiners will expect learners to describe how a microprocessor controls central heating system. Central heating system. So the temperature inside, to control the temperature inside a house. So you can see on the screen the table. You can see a table on the screen. So and this table divided into what? Into two columns. The first column is what? Is the part, while the second column is the component. So we have three parts here. We have the boiler, we have the water pump, and the key pad. So what is the component of the first part, which is the boiler? it warms up the water. It warms up the water. Now the second part, what is the component for the second part, which is the water pump? Water pump pumps hot water around the system to warm up house. Then the last part is the keypad. So we use this keypad to enter preset value, to enter preset value, to enter preset value. And now let's move to the next slide. This is where we are going to discuss how a microprocessor control a central heating system. Now, how does a microprocessor control a central heating system? The first step here, preset value is set using a keypad or thermostat. Using a keypad or thermostat. I believe that every one of you understand what is called thermostat. You know, thermostat is more or less like what? A switch that you can use to on and off. To on and off. Now the second step, a temperature sensor feed back the temperature reading to microprocessor. Don't forget that sensor can only read, sensor cannot process, sensor can only read. So, and the data that sensor is reading is always in analog form. But before microprocessor can process the data that has been entered through the sensor, that data must be converted into digital, into into a digital form using an ADC, which is what? Analog digital converter. The microprocessor compares the preset value and the actual room temperature. So if room temperature equal or higher, nothing happens. Take note. If room temperature equal or higher, nothing happens. So it means that is what is balanced. So nothing will happen here. Now, if room temperature is lower, so these are the two conditions now. If room temperature is lower, microprocessor send a message to actuator to open the gas valve. So it means that there is a lot of what? Code inside the house. So automatically there is a need for warming up. So now the second condition, microprocessor send a message to actuator to turn on pump, as in to pump water. So system continuously monitor temperature. So I hope I am communicating. Yes. So the next slide now is all about greenhouse environmental control. So I will stop this video here. So this video will be the first part of this lesson. So we shall continue the lesson in the second part of this video. So it means that we are going to continue from here.